Okay, let's continue on with our part 2 of solving compound inequalities. And today we're going to look at OR. We looked at AND, now we're going to look at OR. And so what's important about an OR statement? So let's go back to that sending you to the 7-Eleven to get me something from the store. And I mentioned hot Cheetos and Dr. Pepper. So if I told you, go get me a hot Cheetos and a Dr. Pepper, and you came back with hot Cheetos and a Gatorade. Now, if I said this or that, it doesn't matter if you brought me back the Gatorade, because at least you brought me the hot Cheetos. So at least I got one of the things I wanted. And that's what happens with an or statement. You want one thing or another. If you don't get both, it's not that big of a deal, but you've got to get at least one. Okay, and that's where you see at the top of your page there, only one has to be true to graph. That's what we're talking about. Only one thing has to be true in order to graph this compound inequality. So let's take a look at this, where x is less than -5 or x is greater than 7. So we're going to see what this looks like when we graph it. Again, we're going to put some numbers down. We're going to put a 0, and we're going to put a -5, and we're going to put a +7. So we're going to graph this. Let's take a look at x is less than or equal to -5. So we need a closed circle on -5. And we know numbers less than -5 are to the left. Okay, so far so good. And over here, where x is greater than 7, we're going to put an open circle at 7, and greater than numbers are found to the right. So we're going to go over to the right. Wow, this is kind of interesting, because when we did this with AND statements, and we got them going in both directions, we said that this was no solution, that this was impossible. But with OR statements, I want one or the other. It does not matter. I just need one of these to be true, one of these to be able to happen. So I could use the number 8, 9, 10, 11, or I could use the number -10, -12. I can use one or the other. They don't both need to be true. So we're looking for numbers that would satisfy in either situations. So it's a little bit more trickier on the graphs. You can't always say, hey, they're going in opposite directions, there's no solution. Because if it's an OR statement, then it's okay. It can go in those directions. So let's kind of take a look at another graph here. And we have x is less than -3 or x is greater than 0. So let's put our numbers here. We've got 0 and we got -3. Now normally we have 0 and another number, but 0 happens to be our number we're using, so that's okay. We're going to put open circles at both of them, because that's what they're saying here. They're both open circles, no equal sign. Now it says x is less than -3, so we're going to go off to the left here, because that's where x is less than -3. And x is greater than 0, so we're going to go off to the right. Again, this graph is okay because it's an OR graph, this or that, and we're good to go. So we're going to practice solving again, just a little bit. Right, this time I'm going to not be able to give you a compound. I'm going to make you work a little bit. We're going to have two different inequalities. We're going to have x plus 5 is less than or equal to -6, or 3x is greater than 12. So let's take them one at a time, since we can't combine them because they're not the same. So let's do this first one on the left, and let's subtract 5 from both sides. Subtracting 5 does not flip the sign over, so we leave the x less than or equal to a -6 and a -5 is -11. Or we got to bring that or word down with us, right? Because it's going to be our solutions here. This other one, this is a one step as well. We're going to divide both sides by 3. Dividing by 3 does not change the inequality sign over, so we leave the x, bring down the greater than sign, and 12 divided by 3 is 4. So this is going to be our answer when we solve. Okay, we got to make sure, remember when they're separate, like this, we got to make sure that we have the word and or. If you don't do that, then we don't know what's going on. All right, and we're going to graph this. Let me move this up a little bit. And I need the number -11, I need the number 0, and I need the number 4. On -11, we need a closed circle. And on 4, we need an open circle. On -11, it's less than, so it's going to go to the left. and on the 4 it's greater than, so it's going to go to the right. And again, this is a good graph because it's an or statement. Let's do one more before I talk about something special. See if anybody's been paying attention. All right, so here again we have two separate inequalities. They're not similar, so we can't put them together. We're going to have to solve them separately, and these are two-step inequalities. So let's solve the one on the left first. 6x minus 5 is greater than 7, or 8x plus 1 is less than 25. So the one on the left, what we're going to do is we're going to add 5 first to both sides. We end up with 6x is greater than 12. Then we're going to divide both sides by 6. And x is greater than 2. And that doesn't do anything to the sign. We didn't divide or multiply by a negative number. We're going to bring that word or down because we need it. Going back to this other one, 8x plus 1 is less than 25. I'm going to subtract 1 from both sides. And I'm going to get 8x is less than 24. Then to get the x alone, I'm going to divide both sides by 8. And I have x is less than 3. Okay, so let's see what happens when we graph this. I need a 0, a 2, and a 3. Okay, so we need an open circle at both of them. Now it says x is greater than 2. Well, x is greater than 2 is going to take off in that direction, isn't it? X is less than 3 is going to take off in that direction. This is kind of odd. They're crossing over each other. If I want this or that, is there a number that they're crisscrossing over that's going to get left out? The answer is no. It's including every single number on the number line. So if this happens, this is our special. This is what our answer, but really what we're talking about is all real numbers. Okay, so when we had our special, right, when we were talking about and statements the other day, our special was a no solution. Well, our special for an or statement is all real numbers, and when we graph it, we can see what's happening. Okay, so our answer is not what's in blue, x is greater than 2 or x is less than 3. Our answer is what's in red, all real numbers. Okay, so it's real important that we spot that when we have an or statement. Now, I said I was going to see if anybody noticed anything over these two things going on, these two lectures, the and lecture and the or lecture. I don't know if anybody noticed something special going on. Hopefully you did, and you've kind of noticed this, and if you did, that's awesome, because this is what I wanted you to notice, that every time we talked about a less than statement, we were talking about and statements. When it was greater than, we were talking about or statements. Okay, less than were and statements, and greater than were or statements. Let me see if I can flip through this really quick. Yep, there's a greater than there, right? Anytime you spot a greater than in the mix there, there's a greater than. Anytime there's a greater than in there, we're talking or statements. But less than, we're only and statements. And if you take a quick look, just a quick look at yesterday's notes, if you have them handy right there, looking at mine, and you'll notice that it's always got, when we did the compound, right, it's always less than, less than, less than, less than. We can do the same thing with greater than as well. Okay? We can take our answers and put them lowest to highest, and using the greater than sign as a compound, we would end up seeing what was happening. Okay? Let me show you something here. How would that look, like with example 1? How would that look if I was writing it as a compound to show that greater than? Okay? So x is in the middle, right? And we'd have negative 3 over here, because that's the smaller one, and 0 over here, because that's the larger one. X is greater than 0, and this would go here. See how that would be the less than part? Negative 3 is greater than x. Here we have our compound. This is our compound from our or, and you can see that it's greater than. So that's why when we talk about greater than, we're talking about or statements, less than, we're talking about and statements. So hopefully you kind of pick that up. That helps also to see the difference between them.